Good morning, everyone. We are ready to get started with our second session of the morning on this nice rainy July morning. It's a nice July as far as I'm concerned. I'm going to let everyone else introduce themselves. I'm Audrey Harmon. I'm an Oklahoma Ag in the Classroom State Coordinator, and we are so pleased to have you with us today.
So I'm Melody Offiel, and again on this session I'll be monitoring the chat. Hopefully I'll do a little better job. I sent it to all panelists several times. I think I'm waking up now. I'll be fully awake this session. So I want to engage you in some chats. I might be asking some questions. If you have questions about Ag in the Classroom, I'll answer those questions there. Thanks for joining us. We're so excited for Michelle to present to you. So excited to have her join Ag in the Classroom this morning, and thanks for you guys joining us, and we'll get started.
Hi everyone, my name's Emily. I am going to be basically working with the Q&A this morning. So if you do have any questions for our presenters, please put the question in the Q&A box. It makes it much easier for us to mark off and make sure we didn't miss that particular question. Sometimes those questions can get lost in the chat. We'll try to keep an eye on everything, but thank you so much. Hope you enjoy.
Thanks, ladies. And also, if your screen name on Zoom is not your actual name, if you could just comment in the chat box and let us know your name. We're keeping track of who's joining us, and that would be great for us to know. Michelle comes to us from high recommendations from Ginger Reimer, and many of you know Ginger from the Oklahoma Soybean Board. So you know that you're in for a treat if you've met Ginger, because if she's recommending someone, we know she's great. We are excited that Michelle's presenting for us today. She's a 6th grade STEM teacher at Claremore, and she's got a fabulous session with lots of information. So I'm just going to get out of the way and let her get started. Thanks, Michelle.
Thank you so much, Audrey. I appreciate that introduction. I'm excited to be here this morning, and I hope that everyone leaves today with just a couple more tools in their pocket to reach your students, whether it's in a classroom or with distant learning. So I know we're in uncertain times right now, and I'm hoping that you can walk away with this lesson and have a ready to go lesson for you, whether you have to do it at home or in your classroom. So I'm gonna go ahead and start sharing my screen. And I'm so glad everyone's here this morning. It is kind of a rainy day, and just glad that everyone is joining us today. Let's see here. If you guys could give me a thumbs up if you see my screen, that way I know what's going on. Can you all see that, Audrey?
Yes, we can. Thank you.
Okay, excellent. Internet's just a tad bit slow this morning, so I hope you bear with me. On the slideshow, everyone will be receiving a copy of this. So my information is on there. If you want to reach out, feel free to do that. I'll be happy to help as best I can. I know we have a lot of brain power in the Zoom meeting this morning, so I by no means am an expert, but I just hope to share what I can, and I know, and I hope to gain input from those of you that are participating today, because as teachers, collaboration is the best thing. This is part 1 of a 3-part series that we are going to be offering with the Oklahoma Soybean Checkoff Board and the Oklahoma Soybean Farmers. So I hope that you can join us in the fall for the next 2 sessions. Today's session is going to be focused on an engineering challenge, and then in the future we'll have an inquiry lab on photosynthesis, and then we'll go to part 3, which will be some technology with soybeans in deep space. So I hope you can join us for those future sessions. So I'm so glad that you're here today, and I want to thank our sponsors, Ag in the Classroom. This is my first time to present with you, so I'm super excited that we've started this relationship and look forward to the future together. The Oklahoma Soybean Checkoff Board and the Oklahoma Soybean Farmers want you as teachers to have those tools and to be able to teach your students about where their food comes from and where their fuel and fiber and feed comes from. So soybeans are an extremely versatile product, and so we'll learn a little bit about that today. I want to talk just a little bit about my background and myself. Let me back up just one. So this is my 13th year of teaching. So I'm a little, you know, that old saying, lucky 13. We'll see how 2021 goes this year, but I love to teach. It's a second career for me. And I love to learn. I'm a lifelong learner. So teaching just comes natural to me, to want to share the knowledge that I have. And I've taught everything from kindergarten through 8th grade. So I have a pretty full range of those elementary grades. I'm also a space exploration enthusiast. I had an excellent opportunity to go to the Honeywell Space Camp program. And I was immediately hooked because I love space. And once I realized I could teach most of my science content, I was a former science teacher. Through that lens of space, I was just excited. And it gets kids excited, and that's what we want. We want our students to get really excited in our classroom to learn, and space just pulls that in, and especially in the time we live in today. So NASA's making a lot of new missions that they're working on, and so it's just super exciting. I have 2 grown sons and 2 new future daughter-in-laws. Both of my sons are engaged. I couldn't be more thrilled to have them as part of my family. I love to travel. I love to try new things. My husband, Eric, and I have been married for 32 years. So now that we're empty nesters, we like to do a little bit of traveling and going to new places and learning new things. So bear with me, my internet's running just a tad bit slow. I just had to share this with you. If you haven't been bitten by the Bitmoji craze, be careful, because it is definitely a rabbit hole. And this is just another way to engage your students. And there is a Facebook group called Bitmoji Craze for Educators. So if you're not familiar with that Facebook group, I would highly recommend it. It will just be another tool for us as teachers to make our Google Classrooms more engaging. And when you do these pages, you can add links to all of your sites that you go to often. So like this Scratch site that my students go to often right here on the right-hand side of my whiteboard, I'll link that up. So it's just a place where they can go to their daily agenda and be ready to learn. And if they have questions, oh, where's that website? They know exactly where to go. This is just a brief outline of what we're going to try to cover today. I know it looks really full, but we'll try to get through everything today. I'd like to take a poll this morning, and Audrey's going to help me with that. We're just going to do a quick Zoom poll first. And but I do want to tell folks about this poll everywhere. So Audrey, if you want to pull up that Zoom poll for us, we can just kind of get an idea of how everyone is doing this morning.
Michelle, if you want to go ahead and talk about it, it's taking me a little bit, and I will.
Okay, sure, I will. So Poll Everywhere is just a tool that you can use as a teacher. And what's nice about it is it has a lot of different features besides just a poll. You can use things like creating a word cloud with your classroom, having your students asking them, describe yourself in 1 word, or maybe describe how you learn in 1 word, and they can create a word cloud. You can also put in multiple choice questions, a Q&A, and even clickable images. And so it's a great way to engage your students, really, whether you're in the classroom or if you're distant learning, because we all know most of our kids, you know, do have devices on them all the time. And it's just a neat way to pull in using their cell phones, which are usually, you know, like a big no-no, like no phones in the classroom. So the kids like it when they can include their, you know, devices in the classroom appropriately, of course. So here's our quick poll that Zoom also offers. So,
and I just want to say, if for some reason you're not seeing the poll on your screen, sometimes it's at the top of your screen. There's a button that you need to push to see the poll, depending on how you have your Zoom settings. So it looks like only about half of us have voted. So if you're not seeing that poll, look for that button.
So back to poll everywhere, when you can incorporate these clickable images. So this is just kind of what it looks like on the teacher side. And as students are voting, you see these little dots pop up on there. So then you can share that with your classroom too, to get an idea of what poll everywhere looks like. So it's just a neat tool. Awesome. So everyone's enjoying the rain, right? We don't have to water our gardens and our flowers today. Excellent. I'm glad only 6% of you are tired. That's good. And we got 35% that are excited. So that's exciting. I'm excited too. I'm excited to be here as well. To help get an idea of who my audience is, also on Zoom, there's a feature where you can go down to the participant list, which is if you hover your mouse at the bottom of your screen, you can see participant list. If you click on that, you can actually, once you find your name, you can go in and rename yourself. So if you guys would do that for me, that way I have an idea of what grade level you teach. You can just put in, I'm just going to type in 6th grade STEM and then rename myself. And that way, as I'm looking at the participant list, I can kind of get an idea of what you teach.
Since this
Yes.
is a webinar setting, you guys probably are not able to see the participant list since it's a webinar setting. So just go ahead in the chat box. She will be able to see that as long as you set your chat to panelist. So just go ahead and type in there the information that she's asked you to, and don't worry if you're not seeing the participants list.
Excellent. Thank you, Audrey. Appreciate that. All right, I'm going to go ahead and one thing I do want to talk to everyone about this morning too is, as one of the members of the Science Standard Writing Committee, I want to share with everyone the changes that were just approved by the state legislator. By law, every 6 years we have to change or adapt every standard. So I know it seems like we just got new science standards and that we're changing them again, but actually it's tradition, it's customary. By law, we have to do that. So I want to just show you the major shifts that we made in the science standards if you're not already aware of that. And we might even have some friends on here that took part of this process. So the process included teachers of all grade levels in public and private school. And then of course it was open for open comment. So we got a lot of input. And one of the main things we did is we added a play-based pre-kindergarten standard. We didn't have those before. And everyone liked them so well. We got a lot of feedback from the kindergarten teachers that they said, hey, well, we want ours to be play-based as well. So then we ended up changing the kindergarten standards a little bit too. Another area that had a major shift was in the middle school area. So 6th through 8th grade teachers, there's a big shift in that where we felt like the standards needed to be linked together differently to have a stronger connection. And then of course, on all the standards, we worked really hard to increase the clarification statements because those were, maybe some of them were a bit vague. And so we just really beefed those up a lot. And people seem to like what we did on that during open comment. Take note that these will not be assessed until the year 2022-23. So as a science teacher, as a leader in your building, you have time to decide how you're going to implement these new standards. So be sure and take a look at those. But I'm just going to kind of go over those shifts that were in the middle school section, if my computer will cooperate. Let me go back just one. Okay, so here's an example of a big shift that was in middle school. You'll notice that the photosynthesis standard, that yellow represents 6th grade, blue represents 7th grade, and then the red that you see there represents 8th grade. So the old standards, we had photosynthesis in 6th grade, but yet we had cellular respiration in 7th grade. And then all the chemical reactions that go with those processes were scattered between 7th and 8th grade. So it was very, it was just broadly placed on those middle school levels. So as a team, we decided, the middle school team decided to shift those to where they were all on one grade level. So what happened is they all shifted to 7th grade. So if you're a 7th grade teacher, well, really all 6th and 7th grade, you're going to have all of these different standards placed in that same category in the 7th grade. So we just felt like as a team, it would be, it would just make a better connection and allow students to have more support and understanding of photosynthesis and cellular respiration if we included those chemical reactions with that standard. So be sure and check out those new standards. We also changed up the formatting of the standards a little bit, and you can see here, this is what they look like. This top part tells you the grade of the course. And then at the very top, you have the disciplinary core idea. So this is the main part of the standard of what the students would be learning. The next one shows the performance expectations. So it tells you how far to take that standard and where to kind of cut it off at. And then here's that clarification statement I was talking about. And that statement really gives you those assessment boundaries. So as a teacher, it's nice to look at that and know. And then down here in the middle, you have the 3 dimensions of our science standards, the SEPs, which is the science and engineering practices. And then you have that disciplinary core idea again. And then you have the cross-cutting concepts. So it kind of just, to me personally, I like the way they've formatted it because it makes the standard easier to read than what we had in the past. And of course, our Oklahoma science standards are somewhat based on the NGSS, the National Next Generation Science Standards, where it has those 3 dimensions of those science and engineering practices. And that's what scientists do. And then of course the core ideas of what scientists know. And then it also includes those cross-cutting concepts, which is interdisciplinary. So things like cause and effect and patterns. It's something that's going to flow into not only mathematics, but also your language arts area. So those cross-cutting concepts are there. And then I've added a link on here to take you to the frameworks. And what I love about the frameworks is it gives you, as a science teacher, more of that storyline. And most importantly, it tells you what the most common students' misconceptions are. And honestly, even for me, my background is elementary education. And as I was teaching science, I often had my own misconceptions. So I really liked seeing what those misconceptions are, so then I can assess my students at the beginning of a lesson to know exactly where they're at, so I can go from there. Here's another look at those science and engineering practices. There are 8 of them, and today we're going to focus on this constructing explanations and designing solutions. So in Oklahoma, we do pull in the engineering practices into our science standards. So if you're a science teacher, you are teaching a little bit of that engineering design as well. And so today we're going to focus on constructing explanations and designing solutions with our lab. And then I kind of pulled out this standard of Earth and human activity because I felt like what we're doing today, if you're in a district where you have to align all of your lessons to standards, I felt like this standard would be the one that would hit our activity today. So just trying to help you guys out with that. Now I couldn't do a PD without talking a little bit about this new scientific method style of thinking. And I always tell my colleagues, throw out those old linear scientific method posters. We no longer want our students to think that science is a rigid step-by-step process. We really want to start building that knowledge of nature of science with our students. So this is kind of my soapbox. This is an excellent graphic, and I've also attached a link to where you can find a copy of this graphic. And it just shows the fluidity of science, and it shows how it is more of a circular process, because our students need to know that science is a human endeavor and that it's based on, empirical evidence, that quantitative and qualitative evidence, and it changes. Our students need to know that science changes with new evidence, and that's super important. And it ties in even with what we're experiencing today with this pandemic. Things have changed since it first was recognized, and that's because science is based on new current evidence and data. So this is just a better, to me, just a better visual for students to help teach that nature of science. Let's see if we can move on to our soybeans. So that's why we're here today. The reason I love soybeans is the versatility of it. And so I want you to think, and you guys can put this in a chat room, and Audrey, if you can help me when they do, because I can't see the chat since I'm presenting. How many items in your kitchen do you think are made from soybeans? Do you think it's 1 to 5, 6 to 10, or do you think it's 11 to 20 items? So I'll give you guys a minute to pop that in the chat room. Or maybe you think it's 0,
Okay, we've got lots of 11 to 20, 6 to 10, several 6 to 10 coming in.
Okay,
Some more
excellent.
11 to 20. Some more 6 to 10. So somewhere between 6 and 20 is our guess, Michelle.
Okay, excellent. Well, those of you that, chose 11 to 20, you're probably right on. Soybeans come in many different varieties, and the byproducts of soybeans are very versatile and come in many different ways. So most of us are familiar with tofu, edamame, miso, but what you might not be familiar with is how they take the soybean and apply it to different processes. So if you have, processed foods in your cabinets that include things like thickeners or gum arabic, which a lot of our foods have that included in it, stabilizers, MSG, monosodium glutamate, all of those items come from soybean. And so in your pantry, I didn't make you go dig in your pantry, but if you have cake mixes or chicken broth, chocolate, I know I've got a lot of chocolate in my pantry that I hide back there sometimes, peanut butter, all of these different food products include soybeans. So it is a super versatile legume that NASA's looking at because of its versatility. So this is something that's going to help our astronauts in the future. And like I said, most of us are used to soybeans being in our food, in our oils that we use, but you might not know that the #1 consumer of soybean are things like our poultry and pork and beef. And so soybean is used for feed for these animals that we enjoy. And something I learned new is it's also used in feed for our fish in our fish farms, which is where most of our fish comes from. And so it's super versatile, because if you look at the bottom of that slide, things like paint stains and paint, asphalt, even our tires, the rubber, they add it to the rubber of our tires to help them be more flexible. Soybeans, if you drive a Ford Mustang convertible, I know most teachers do drive those, your cushion is going to be made out of soybean. It's also used for biodiesel fuels. And this bean just has so much versatility and a lot of prospects for the future. So I want to introduce to you AstroBean Glycine Max. NASA is looking at the next legume to study on the International Space Station, and Glycine Max is in the running. They think he's going to make it because of his versatility. So we're excited, and I hope we'll know by probably 2021 which legume they choose to study up at the space station. Now, they've studied soybeans before, but this will be on a different level. This will be on looking more at those nodules and that nitrogen process that soybeans have the ability of doing. So that's why they're looking at legumes at this next time. So we'll find out soon which one's going to happen. So why do we care about space, and why do we even explore, and why do we care if soybeans get up there to space? What difference does that make to all of us that live on Earth? So I have a short video I want to share with you about exploration, space exploration.
5, 4, 3, 2, 1, 0. Liftoff. We have a liftoff.
All right, so yeah, our sites are on the moon. And so with the ISS, this is actually the 20th year anniversary for the International Space Station. And just all of the technology and innovation that comes from our astronauts, not only American astronauts, but of course astronauts from all over the world, coordinate and collaborate to make this a possibility. The innovation that comes from that helps us on Earth. So we gain a lot of new technology, new spin-offs, things like our soybeans. If we can study soybeans and how they function in extreme conditions, we can take that technology back to Earth, because you know, we have extreme conditions right here in Oklahoma as well. And so especially when you think about drought and water. And so what they do on the space station will only help and give us advantages here on Earth. So we have, you know, we had an exciting launch this summer with, you know, it had been 10 years since we launched astronauts from American soil. So that was a huge deal this summer when Bob and Doug launched with SpaceX back up to the space station. And we have an exciting launch on Thursday, so I hope you can tune in to NASA. They're going to be launching the next Mars rover, Perseverance. And there is so much curriculum that you can add and incorporate into your classrooms with that launch that's getting ready to take place. And yes, we're going back to the moon. So in 4 short years, we are going back to the moon. And yes, ladies, we're going to have a representation this time. So they are going to be bringing women to the surface of the moon. So that is super exciting for our girls in our classroom, who sometimes we don't always reach with STEM and science and engineering. And we need to, you know, make sure that we show scientists and engineers that look like them and talk about that in our classroom as well, to inspire those young women as well. So every, you know, every 16 times a day that space station rotates around our planet. And it's just exciting to know that we're eventually going to be back to the moon, and we're going to be, the goal is to, once we get back up there, that we will build a small gate, what they call a gateway, on the surface of the moon. And then that is actually going to allow us to eventually get to Mars. And so that's the destination we're looking at. The Artemis program is well on its way. And the Orion spacecraft, which is the module that our astronauts will be in, it's already built and being tested, you know, down in Houston in that huge pool buoyancy lab that they have down there. So it's super exciting, all the things that are going to be happening with this program. One other thing I like to do with my students is we like to follow the space station. And so there is a website that you can go to called Spot the Station and sign up for alerts. And so I always alert my students when they can go out and see the space station in the sky. And if you've never done that, there's just some kind of amazing connection when you see that spacecraft going across the sky. It's not an airplane. It looks different than a satellite. So you definitely know that it's the space station. And it just always is thrilling to know that the men and women from around this world are collaborating together up there on that piece of metal that's about 1 million pounds and about the size of a football field. So it's pretty exciting. So why do we want to grow plants in space? And the answer to that, of course, is food. You know, we want our astronauts to have a variety of food. Most of their food, even though they've spent a lot of time and energy into making their food taste really good, it's still freeze dried. And so having the ability to give our astronauts that fresh produce that has those vitamins and vitamin, C and vitamin K, it's just so important. The soybean actually is a high source of B1. And that's another reason why they're looking at the soybean to get up there into the space station and possibly on the surface of the moon and eventually Mars, because it does have those qualities. But it also brings a psychological well-being to our astronauts. So it's almost like a little touchstone of Earth, I guess you could say, when they can smell those plants and they can touch those plants and just have a little bit of home with them while they're up there on the space station. So this last, over a year ago, when Captain Scott Kelly was up there, he was the astronaut, of course, that lived on the space station for a year. They decided to try growing plants that flower, because if we're going to have fruits on the moon, we need to know how these flowering plants operate in microgravity. And so he got attached to growing these zinnias, and it was kind of his baby project because he was there for the longest. And he was very attached to these plants, and it just brought him joy and kind of had a morale building effect to the crew as well. And on Valentine's Day, he was, I guess you could say this was the first space Valentine's, where he picked all the flowers and took a picture of them up there in the big window that the Germans built, the cupola that's on the space station that you see a lot of pictures of online. So they had success, but it was challenging in that microgravity environment. This is just a rendition of what possibly a future lunar base might look like. And you can see these compacted greenhouse right here where they're growing plants with electric lights. And then here's another photograph, an artist, I'm sorry, it's not a photograph, it's an artist rendition of what a greenhouse might look like on Mars. And so you can tell this rendition is more of a module that possibly was connected to a rocket to get up there. And it's exciting to tell our kids, if you go into that industry of agriculture, you could be an astronaut. And so even today, we have a group of scientists and botanists and biologists who work down at the Kennedy Space Center with a program called Veggie Team. They're the Veggie Team. And so they do a lot of science research there at Kennedy Space Center. to help decide what labs are going to go up to the space station. So as kids think about their future careers, they really need to think about space exploration. NASA employs so many different scientists and people that we are going to need our students for future Mars farmers. So it's something definitely that kids can get excited about. Of course, when we get up there to space, we're going to have to know how to sustain these gardens, these plants that we're growing up there. And so I have just a short little clip of how they filter the water on station.
On station, we recycle wastewater to get fresh drinking water. This recovery and filtration process includes our urine, moisture we exhale, and sweat, along with the water we use to bathe and shave. It works like this. When we use the bathroom, urine is collected and pumped to a distillation assembly. The assembly spins, pulling the urine to its walls. The urine is heated to evaporate water from the waste and then condensed in the outer chamber to form distillate. Next, the water is pumped to a tank where it is joined with the water recovered from cabin air created by crew sweat and respiration. Down the line from there, odors and any other contaminants are removed with heat. Then iodine is added for microbial control. Our water is checked often to ensure it meets water quality requirements. It is also monitored closely for bacteria, pollutants, and proper pH. The pH scale ranges from 0 to 14 and is a tool used by scientists to measure the strength of an acid or base. Our water is required to be in the 6.0 to 8.5 range. The end result of the entire process is clean drinking water that we get to enjoy every day.
So yeah, they did say urine. So of course, whenever you talk about space, the first question kids are going to ask you is, how do astronauts go to the bathroom? And so when I was at space camp, they had a set up that looked just like what it does in the space station. And so we were able to take photographs and get some information from the experts there as, you know, how they go to the bathroom. And so the piece that I'm holding in my hand, you guessed it, that's what they urinate in. Men and women, they're working on changes of that, of course, for women. And then, of course, when you have number 2, you got this little gadget that you have to sit on and use. So it's something that, you know, just is fun to talk about about space travel. So at this point, I want to add just a brain check, and we're not going to go to it because of time's sake. But if you, as a teacher, have never used Kahoot, kids love Kahoot, and so it is a just an online quick assessment that you can do in the classroom, and the kids can use their cell phones to log in, and it's just a great way for kids to participate and be engaged in your learning. So this is what it looks like. Comes up, of course, I should have the Kahoot music on here, because if you've used it before, you recognize that music, and the kids do too, and they really enjoy that. So it's a great tool, digital tool to use in the classroom or not in the classroom. After I presented this information to my students, I would help them, kind of guide them to come up with a driving question. So if we're going to grow soybeans on the surface of Mars and sustain that crop, how are we going to do it? What do we need to know about the environment of Mars? So at this point, I would guide them to do some brainstorming of what information we need to find out, do some group research with some different websites I would guide them to go to find their answers using a reputable website. But one tool that I just learned about this summer is Jamboard, and it is part of the Google Suites app. If you're not familiar with that, it's a great way for kids to share their information that they've learned. And it helps you can manipulate it as well. So this is what it looks like. It's a very simple application that kids can use. So you create the Jamboard, and then as kids come in, they just come over here and click on the sticky note, and they can add a sticky note as to giving some information about what they found out about the environment of Mars. And then as a teacher, you can go in and move them around and manipulate them. The only drawback I can think of as a middle school teacher for Jamboard is that yes, they can delete other stickies. So you would definitely have to go over your protocol and procedures in using this tool. But maybe with teacher feedback, maybe they'll change that, because Google has been really good to listen to teacher feedback. So that could be something that might change in the future. But definitely involving your kids in research is important part of the process of learning, and gives them that deeper concept of learning. So here is your mission. You are one of the first space farmers on Mars. Unfortunately, the water recovery system on your Mars base has stopped working. You're 7 minutes away from Houston, receiving your distress signal, and you're at least 7 months away from receiving any parts from Earth. With limited supplies, you have to design, build, and test your own water filtration system to clean your urine and sweat. You will use the clean water for drinking and watering your soybean crops. Your water must have a pH between 6.0 and 8.5 before you can use it. So that is your mission. Your supplies include empty plastic bottles, paper towels, rubber bands, cheesecloth, pH test strips, coffee filters, aquarium, gravel, sand, activated carbon, beans, charcoal, pasta, and cotton balls. So at this point, I'm going to stop sharing my screen so I can go through this lab with you. I think we have time to do it. But before I start, are there any questions up at this point related to what we talked about?
One question that came in was, did they explain how NASA trained them to use the toilet correctly? From what they said, it was quite embarrassing.
Oh, well, they didn't, they talked a lot about a lot of different things, and I don't recall the training on that, but there are a lot of different videos out there on NASA's website and in the YouTube, on the YouTube channel that go into more detail about the training on that. So, so yeah, I know that I can only imagine that it would be embarrassing to train on that, so.
And several had not heard of Jamboard, so thanks for sharing that.
Yes.
And right on time for demonstrating your lab.
Excellent. Well, I'm so excited that you all learned something. I just learned about Jamboard myself this summer. So I'm just like everybody else, just trying to figure out what we're going to do with you know, how we're going to teach distantly, especially as a science teacher. So I'm going to go ahead and hopefully my cord. So can you guys see me? Hang on. Come over here. I'm sorry. I'm going to Can you guys hear me?
Yes, we can.
So you have these supplies right in front of you. We've got the sand, gravel, beans. I also have macaroni. I've got cheesecloth. I've got cotton balls and coffee filters, and also activated carbon that you do want to pre-rinse that activated carbon. So I have pre-rinsed that. So what we're going to do first off is you want to make sure you talk to your students about safety. I am a stickler on safety in my lab, so I always wear my safety goggles and model that for my students. You also want to tell them not to drink or eat any of these ingredients that we have in front of us. Those of you that teach middle school, you know how important those safety protocols are in your science lab. And so just make sure you reinforce that. So the first thing that we're going to do is you're just gonna have your students bring a bottle. I would also do this as a group activity. That way they can kind of help each other. You can keep this very open-ended to where it's not so prescribed. Now in the slideshow, I have, you know, listed everything in the steps, just more for your sake as a teacher so you can see where you're going with this. But when I teach this lab in my classroom, I don't tell them how to create the filter. I let them, you know, use that engineering process to try different models, and then they can test it and then
change it and adjust it as needed. So I like to leave this very inquiry based to where it's not so prescriptive and cookie cutter, you know, type. And that goes for asking the kids as to what type of evidence they need to collect, or and let them come up with those ideas instead of just handing out that data sheet that I have on your slideshow. You can let them come up with what information they need to collect as they're doing this lab. So that gives it more of that inquiry feeling. So what I do is, and the kids will figure this out too, I will cut the bottle about 1 inch from the bottom, and I'll do that on 2 bottles. And then I want to, you know, let's say our kids decided part of the data we needed to collect was the mass of what these water filters are going to be, because that's important in space to know what the mass is. So I'm going to turn on my scale. And I've got a digital scale, but if you have, you know, an old slide scale, balance scale, you can use that as well. I'm going to take off the lid to find my mass of this empty bottle first. And it's about at 17 grams. And then I'm going to reweigh it after I build my system. So I'm going to set that aside for just a minute. I've given you a recipe on making this wastewater, and you can use that recipe. I've also seen teachers use just a bottle of Italian dressing, and they pour in the bottle of Italian dressing and fill the rest up with water, and that works as well. So you don't have to follow that prescription there that I've added in the slideshow, but it's there in case you need it. So I'm going to measure out 200 milligrams, and this is a really great time when you can talk about science tools and using the metric system and why scientists use the metric system, because my kids always you know, want to know why they do that. So we talk about why it's consistent in the science community if we do. So this is my wastewater, and as you can tell, it looks very urine-like. So I did that on purpose with some yellow food coloring. And I'm going to set that aside. And then I'm going to take my pH strip. So hopefully as a class, they've decided, you know, after watching that video that, yeah, they do need to know what the pH of the water is. So you're going to dip this in for half a second. And then when you take it out, you'll use the scale that comes with these strips to kind of see what your pH is. And mine is running about 4.5. So we're not in that safety zone yet. Now, once I've tested the pH of my water, I'm also going to have my kids just make qualitative observations. So they're going to look at, you know, the debris that's floating in there, and you know, come up, you know, talk about the color and the clarity and all of that as well. So once they do that, they're going to start building their system. So the first thing that I would do is I'm going to put some little bit of cheesecloth on the end of one of these bottles. And I've also included a video of this lab that's in the slideshow. So if you forget all this stuff, there's a video that you can refer back to. So once I do that, I think I'm going to add some cotton balls in here. And then I've chosen to put in a little bit of macaroni. I'm going to add that. And then I think I want to add a coffee filter because I want to put some sand in my system as well. So I'm going to add that sand in there. And then I'm going to put in a little of this aquarium gravel that I had. And finally, I'm going to end up with this activated carbon. So in the video, you'll see my first fail. I included it because we all often have failures in science, and that's how we learn, especially with that engineering process. And so in the video, the first time I forgot to rinse my carbon, it turned my water black. And so you'll see that failure in there. And we talk about failures and why they're important and how scientists learn from those failures. I did remember to rinse this one. So this is rinsed activated carbon that I'm going to add in there as well. So now that I have this built, I'm going to weigh my system so I can get the total mass of this system, because that, like I said, is important. And this is where they might need help from their friends and from their teammate in holding this. Oops, let's see what's going on. Let me turn this off and back on. All right, so now it's running about 354 grams. So we're just going to subtract that 17 from that and then come up with our total mass of our system. The next thing I'm going to do is I'm going to take my second bottle and I'm going to put it here. Now, a lot of students, they might even double up on their filtering system. So they have that opportunity to do that as well. And at this point, you can also cap the bottom of this bottle if you choose to, and have a cap on it to collect the water. But since I do have a second beaker, I'm going to just take that cap off and hold it over the beaker. So now I'm going to slowly pour my wastewater through my system. Now remember, we started with 200 milliliters of wastewater, so we're going to want to see what happens and see how much volume we lose. And as this water is going through, it definitely has cleaned out all of the debris. The water is slightly cloudy, but not too bad. The color is lighter. It's not as yellow as what it was, but it's still a little bit yellow. So as an astronaut, I don't know that I would want to drink this water. But look at how much volume we've lost. We're now at 50 milliliters, so a substantial loss of volume. So that might even be the data that you collect looking at those different things. And then of course, you're going to finish up by testing your pH again and seeing if that made a change. So let's do that really quick. I think we've got a second to do that. And if I look at my pH, it really changed just ever so slightly. It looks like maybe it's back up to 5.0 now, but not a huge change. So then you have opportunity to talk about that with your students, thinking about the different supplies that you can have to change those different things.
Michelle, thank you so much. This has been a fabulous session, and I'm sure everyone's like me and could watch another hour's worth, but I'm unfortunately going to have to cut you off. So is there any last minute concluding statements that you need to say?
Well, one thing that I'd really like to talk about before I leave is just thanking you guys again for hosting me. And really, on behalf of the Oklahoma Soybean Board, thank you all for attending this session. I really appreciate it. I hope you gained a couple of things new. And when you get the slideshow, if you have any questions, my email is on there. Feel free to email me and ask me questions. I'll be happy to help as best I can. So, and then look for those next few workshops that we're going to offer this fall. So I hope you guys can join us for that. And thanks again for hosting me, Ag in the Classroom. This has been a great experience, and I look forward to our future working again together.
Yes, thank you so much. And if you're interested in those workshop sessions with the Oklahoma Soybean Board, be sure to like their Facebook page, which is Cool Beans, and they post their information there. So thank you again, and thank you to everyone that joined us. We're going to close out this session so we can get our next one started with Connie Seiner. So thanks for joining us, and we'll see you in just a second.
Thank you. Bye-bye.